Hello everyone, my name is Arvind and today's topic is password hashing and hacking. In our last section, we have already covered the hash function. Let's do a quick recap. So this is our plain text. We have applied one hashing algorithm and we have got a fixed length hash value based upon the hashing algorithm, and there is no way to get the plain text back, unlike encryption and decryption. When you create an account in e-commerce, banking, or a social media website, when you enter your personal details like username and set your password on the login form, it actually stores these details in the database. So next time when you log in with your credentials, it matches with the details stored in the database and let you to log in. There are three ways to store the password in the database. The first one is the plain text, which is the worst way of storing the password, because if your database got compromised and if hacker get into the database, he will get the username and password of all the users. The next way to store your password with some encryption method, that is also not the best solution. There are three main reasons that this is also not the recommended way of storing the password in the database. The first one of managing the keys. So you have to manage a unique key for each and every user. If you lost the key, the user will never be able to log in. Second, if you keep the same key for all the users, if a hacker got it, he will be able to decrypt all the passwords. Third reason, it's an encrypted method, so there is definitely a way to decrypt it. The hacker will try all the possible ways to decrypt the password. So that is why this is also not the recommended way of storing the password. The best way of storing the password is hashing. The first reason is there is no way to get the plain text back. Second, it doesn't matter with the input size, you will always get your hash value of fixed length. So by seeing the hash value, you cannot predict the password length. So overall, when you enter your username and password, so it converts your password into a hash value, and your database match this hash value with the stored hash value. If it matches, it lets you to log in. So it also proves that nobody has the password of your account except you. Even though all the big e-commerce, banking and social media websites do not store your password in a plain text, they store the hash value of your password. Still, your password got compromised and hacked by hackers. When a hacker get into a database, these are the three common attacks they use to get the password from its hash value. The first one is rainbow table. It is actually a pre-computed lookup table which used for reversing the hash function. So it's a pre-computed lookup table where they have most common passwords in the table with the hash value of it, and once they get the hash value, they will try to match it. Once the match is successful, they'll get the equivalent password. Next, brute force attack. In this type of attack, they systematically check all possible passwords and passphrase using some computing power. And the third one is dictionary attack, where they try all the strings or some words available in dictionary. That is why it is always advisable that do not pick your password from a dictionary. Based upon a survey, these are the top 10 most common passwords used by the users all over the world. If you look at here, the password 123456 is used by around 2,90,000 people. With this probability, if I get into a database and if I generate a hash value of this, I will definitely be able to crack someone's password. So this is the sample rainbow or pre-calculated lookup table. Here I have generated the hash values of most common passwords. If I get this hash value from database, I will try to look up this in my pre-calculated table. If any hash value matches, I'll get the password. So this is how a rainbow or a pre-calculated lookup table works. That is why it is always advisable that always use a unique password. So here in this table, I have calculated the hash value of this password, which is 123456, using different hashing algorithm like MD4, MD5, SHA-1, SHA-256. If you look at the first two algorithms, these are of just 128 bits. So with high computation power, it would be easier to break this hash value. That is why we have some advanced hashing algorithm of 256, 320 or 512 bits. Now I'll show you an example, kind of a small lab, that how a hacker cracks your password using rainbow or a brute force attack. This is an online portal that tells if an attacker tries to crack your password using brute force attack, then how much time does it take to crack your password. Now let's give some common password. Let's say ABC123. So it says that if you try offline, it will take less than a second to crack this password using brute force attack. Let's make it more complex. Now it says that we can crack this password less than 2 hours, and if we apply massive cracking array scenario, it will take less than 6 seconds. Now let's make this password more complex. Now it says that offline it takes less than 10 months, and with massive cracking array scenario it will take less than 7 hours. That is why it is recommended to use complex password and keep changing your password with a fixed interval. Let's say this is your password and it takes around 10 months to crack your password offline. Now let's make it more complex and add an uppercase later. If you look at here, it takes around 18 centuries to crack this password offline, and it will take around 2 years with massive cracking error scenario. And let's say this is your password, and if you keep changing your password in interval of 1 year, then nobody will be able to crack your password using brute force attack. On this portal, I will generate the hash value of my password. Let's say my password is ABC123. Now I will generate the hash value of it using MD5 algorithm. Now I'll press this button and it will generate the hash value of my password using MD5 algorithm. So this is the hash value of my password ABC123. Now I will copy this hash value. Now I'll use another portal. Now on this portal, I'll get the password from my hash value. I'll paste it here and I'll press this button. So within a second, I have got my password from my hash value, and it also tells that I have used MD5 hashing algorithm. Now you may think that how does it work, because there is no way to get the plain text from my hash value unlike encryption and decryption. So just scroll down a little and here is the answer. So this website says that they use a massive pre-computed lookup tables for MD5 and SHA-1, and they say that they have a 19 GB 1.5 billion entry lookup table. Now I'll show you one more lab of brute force attack. This is a zip file. Inside it I have a password protected text file. Now if I try to open this text file, it will ask for a password. So the password is 1234. Yeah, it's working. Now I'm using one third-party software that allows a brute force attack. Now I'll select that zip file. Now let's say I already know that password is in digits and password length is 4. So I'm not telling the exact password to this application, I'm just telling the probability. I can also say that password contains space, symbols, but I do not want to consume more computation power as it is just for a demo. Now once I will press start, it will try all possible values from 0 to 9 of length 4. So if you observe, in few seconds it cracked the password. Overall, it proves that just keeping the hash value of a password is no more secure and open for the attack. To mitigate these attacks, all big websites use some method. So let's look at these methods. To mitigate these attacks, we have some method. The first one is salt and pepper. Salt is a simple random value generator for each password. It means that it adds a random value to your password. So let's say your password is ABC123 and the random hash value is this one. Then it adds both of them and then generate the hash value of this combination. So these are the key benefits of adding a salt to your password. The first one is it makes your password more complex and difficult to crack. Second, it makes the password unique for each user. So earlier, suppose two users have same password, that is ABC123. So the hash value of both the users will be same. Now if we get the hash value, we can crack the password of two users. So even if the password of two users are same, but by adding a salt, we are making both these passwords unique. The next method is pepper. It is also a random value like a salt, but it is common for every user and it doesn't store in the database. So we can say it's a secret unique value. So let's say this is your salt password, which is the combination of your password and salt. Now in this salt password, we will add a pepper, which is a secret unique value, and make it more complex. The next method to mitigate the attack by adding a cost using some algorithm like brypt, scrypt and argon2. So these algorithms take the password as input and add a cost to it. And this cost defines the number of rounds the algorithm goes through. So overall, this is your password. We have added a salt and pepper and added a cost to it and increased the number of rounds of the algorithm and made it more complex. So this is the overall look of the protection layers of your password. So this is your password, which has a layer of salt, and then we have a layer of pepper. We have generated the hash value of it. Now we have added a cost to increase the number of round for the algorithm, and we can also add an encryption method with the key. At the end, let's add a summary to it. Since our computers become fast and these attacks against these algorithms becomes easier because they can try more combinations in shorter time span. So by increasing these parameters like salt, pepper and cost, we can make the hashing algorithm resistant against these attacks. So I hope the session has been informative. Thank you so much.